Now we're going to kind of circle back to where we began the semester, and that's talking about logic and statements. But we're going to look at logic a little bit differently. Before we thought of them as sort of just a sentence structure that had a true or false value. Now we're going to look at them more like logical operations, more like arithmetic. So the first thing we're going to do when we do this is to review the logical operations way back at section 0.2 in the beginning of the semester, in case you've forgotten them. And we're going to introduce some notation for them. Then we're going to show how to summarize logical operations using truth tables. And we're going to do some examples. So what symbolic logic is about is interpreting logic as some kind of arithmetic operations. Sort of like we do with numbers, with addition, multiplication, and things like that. And if you want to think about how we think about that, the way addition works is you take two numbers, say 4 and 5, and then you combine them and turn them into one number. Now we do that in a very systematic way, but essentially we're taking two numbers 4 and 5 and turning them into the number 9. We're going to do something very similar with logical operations, except they're going to be with quantities whose values are either true or false. And, well, what are those? Those are exactly statements. So here are some important logical operations and their truth tables that we've actually encountered before. Keep in mind that the variables are statements, and those statements can have precisely two different values, or one value out of true or false. So we're going to start with the AND operator. The symbol that we're going to use for that is an upside down V. And instead of we've given AND as a rule, what I want to do now is set up a table that tells you, no matter what the values of P and Q are, what the value of P and Q is. So what are the different ways that you can have P and Q be true and or false? Well, you can have them both be true. In that case, P and Q is true. You can have one of them be true, P true and Q false. That gives you false. You can have the true and false the other way, where P is false and Q is true. That also gives you a result of false. And if they're both false, you also get a result of false. So if you didn't know how exactly AND worked, you could look at this table and figure out whether P and Q is true or false for both of them, and then figure out whether P and Q is true or false. So for OR, it's going to work very similarly. Our symbol is a regular V this time. And so we're going to look at all the ways we can have P and Q be true or false, and then see what the OR statement is going to work. Now, if P and Q are both true, then P or Q is going to be true, obviously. Only one has to be true, and if both of them are true, all the better. If one of P and Q is true, then we're still going to get true. So if P is true and Q is false, we get true. If P is false and Q is true, we still get true. The only time we get false is if P and Q are both false, and then P or Q is false. Another one that we worked on was negation, right? The not operator. That one has a funny looking symbol. I don't even know what to call that one, but I don't know, a little hook maybe. And so that one is an operation that we don't do on two statements. We just do it on one statement, right? We take one statement and then we take its negation. That one statement P can be either true or false. If P is true, then not P is false. And if P is false, then not P is true. Remember, not P changes the truth value of P to the opposite of what it starts off with. So if it starts off with true, you get false. If it starts with false, you get true. We had the conditional statement, the if-then statement. That one we use an arrow going from left to right to indicate that. So if P and Q are our statements, then P implies Q is the same as if P, then Q. And remember, this one is almost always true. The only time it is false, remember, is when P, the if part, is true, and Q, the then part, is false. So if they're both true, you get true for the implication. If P is Q and true is false, you get false for the implication. And if P is false, no matter what Q is, it's going to be true. So false implies true. Yeah, that's true. False implies false. Yeah, that's true as well. So it is also possible that we may encounter some statements that are a little more complicated. For instance, if I had P implies Q and R, that has two different operators in it and three different variables. So we got to be careful on two fronts. First of all, when we set up our truth table, now we've got to find all the ways that we can get P, Q, and R to be true and or false. And it turns out there are 8 ways that you can do that. And here they are. The top row is when they're all true. The next 3 rows are when 2 are true and 1 is false. And the next 3 rows after that are when 1 is true and 2 are false. And then the very last row is when all 3 are false. So we're going to take one at a time. You don't want to bite off more than we can chew. So the first thing we're going to do is look at P implies Q, which means we care about the truth values for P and Q. And since we know kind of our little cheat is to look for where P is true and Q is false, because that's the only way that P implies Q can be false, we get that on the 3rd row and the 5th row. And all the other ones have, well, something else. If they have something else, they're going to be true. All right, so next we're going to look at P implies Q and R. So we're going to want to look at the last 2 truth columns that we filled out. And P implies Q and R is going to be true precisely when both of those are true. So we can see that's going to happen in the top row. We have a true, true. In the 1, 2, 3, the 4th row, we have another true, true. And then in the 7th row, we have another true, true. Everywhere else is false. All right, so now I think you're ready to work on the in-class activities. The PDF file that you're looking for is called Truth Tables.